Greetings and welcome to everyone. Today we will be discussing highest common factor. So when understanding highest common factor, and I'll just write it out for us. Highest common factor, also commonly known as HCF. Very simply, the highest common factor is whenever you get at least two or more numbers, then if you need to find the largest factor that is common to those numbers, then that largest factor common to those two numbers is the highest common factor. So the highest common factor is the largest number that is common to at least two numbers. It's the largest number that is common to at least two numbers, right? So it's at least two numbers. So you can find the highest common factor for three numbers and four numbers and an infinite number of numbers, right? So when we think about the highest common factor of maybe some numbers, let's think about if you were asked to find the highest common factor of, and let's say you had the numbers 600, 250, and 90, right? Then we know in order to express, firstly we need to express each of these numbers as a product of its prime factors. And for that, we can use the ladder method, which we learned how to use in the previous video. Then after doing that, depending on the expression that we see, right, in order to find the highest common factor, very importantly, we need to determine what? First, we need to determine which bases are common to all numbers. And secondly, we need to determine the lowest level of each common base. And then lastly, we would need to multiply all common bases with lowest exponent by each other. Then of course this value will equal the highest common factor. So we all know when we think about b to the n, we know that this would be the base and this would be the exponent, right? So 3 squared, the base would be 3 and the exponent would be 2. Yes, this must be very clear before we proceed. Yes, I hope that's clear. So once again, we need to use the ladder method, right? And in the previous video, we went through extensively how to use this ladder method. So once again, I firstly have to write out my prime numbers, right? 2, 3, 5, 7, 11, 13, and so on, right? Then I create my ladder. And this would be specifically for the number 600. I'm not too sure how far it will go. So I need to do this for 600. I need to do this for 250. And I also need to do this for 90. So let's go with 90. So what is the smallest prime factor that's divisible by, that 90 can be divided by without leaving a remainder? It's 2. 90 divided by 2 is 45. 45 divided by 2 gives me a number with a remainder. 45 divided by 3, it gives me a number without a remainder. What's that number? 15. 15 divided by 3, can it give me a number without a remainder? That's yes. What's that number? 5. Then 5 divided by what will give me a number without a remainder? That's 5. Then already we know 5 divided by 5 is 1. Then if I have to express this, and I'll just try and divide this with red so that it's very clear when I express it. Actually, we don't have to do it like that. Therefore, I know for my very first set, I know 90 can be expressed as 2 times 3 times 3 times 5. And to write that more simply, it would be 2 times 3 squared times 5. Then when I look at 250, can 250 be divided by 2? Yes, it can. It's 2. That gives me 125. Is 125 divisible by 2 without leaving a remainder? That's no. Then I go to my next prime factor, which is 3. Is 125 divisible by 3 without leaving a remainder? And that answer is no. Then I have to go to my next prime number, and my next prime number is 5, right? It's 5. Then is 125 divisible by 5? Yes, it is. Then what does it give me? It gives me 25. Then is 25 divisible by 5? Yes, it is. And that gives me 5. Then is 5 divisible by 5? Yes, it is. And it gives me the final answer as 1. Then I can then express the number 250 as, so I can express the number 250 as 2 times 5 times 5 times 5, which equals to 2 times 5 cubed. Then I can go to my number 600. Then for my number 600, I go follow the same process. 600 divided by 2 gives me 300. 300 divided by 2 gives me 150. 150 divided by 2 gives me 75. And then, can 75 be divided by 2 without leaving a remainder? That's no, right? Then 75 divided by 3, does it leave a remainder? No, it doesn't. Therefore, I can put 3. Then 75 divided by 3 gives me 25. Can 25 be divided by 3 without leaving a remainder? That's no. Then I have to go to my next prime factor, which is 5. 25 divided by 5 is 5. 5 divided by 5 is 1. Then the value there is 1. So if I had to express the number 600 as a product of its prime factors, then it would be 2 times 2 times 2 times 3 times 5 times 5, right? 2 times 2 times 2 times 3 times 5 times 5, right? Gives me 600. Then to write that more simply, it would be 2 cubed multiplied by 3 multiplied by 5 squared. So something that's just a disclaimer, right? We know that any number to the power of 1 will always be that number, right? But any number to the power of 0 will be 1. So essentially, the number 3 can be written as 3 to the 1, and 2 to the 1 to the 1, 5 to the 1, right? So now, once again, in order to find the highest common factor of these three numbers, firstly, I have to determine the bases which are common to all numbers. What bases are common? So here, it only has the bases 2 and 5. Here, it only has the bases 2, 3, and 5. Here, it only has the bases 2, 3, and 5. What is common to all bases? 2 and 5. Then, the highest common factor must definitely be something of 2, something of 5. Then, within these common bases, I have to find a base which has the lowest level exponent. So the exponents range from 1 onwards, right? Then I must find the one that's closest to 1 or is 1. Then when you think about some of the bases that you have here, when I think about the base of 2, right, here I have 2 to the 1. Here I have 2 to the 1. Here I have 2 to the 3. Then which base of 2 has the lowest level exponent? It's 2 to the 1. Then when I look at the base 5, I can see that this is base 5. 5 to the 1. Let's maybe use a different color. This is 5 to the 1. This is 5 to the 3. This is 5 to the 2. So which one has the lowest level exponent? It's this one, 5 to the 1, closest to 1. This is 5 to the 1. Then the highest common factor would be 10. Then this would be your correct answer. So I hope through this method we were able to come to see the highest common factor of a number. And thank you so much, and I will see you in the next video.